These are the assumptions that we made when making our calculations. We assumed that there was a constant acceleration throughout the motion of the swing from start to finish. We then had to assume that the swing was made using ideal form. This meaning, there is no sway in the body or shift in weight of any sort. The only motion recognized is the motion of the club and arm as the arm pivots around the shoulder. We then assumed that air resistance was negligible and therefore zero, and that there was no resistance due to the contact of the ground. We also had to assume that the club was a rigid body and did not bend while being swung. Lastly, we assumed the motion of the swing to be two-dimensional due to the lack of ability to measure three-dimensional motion. After identifying our assumptions, we laid out our procedure for analyzing the scenario. We first established the formulas needed to solve for our unknowns. Then we analyzed the video of the club being swung to help find certain required variables. Once found, we were able to calculate our desired unknowns and finally come up with our overall results and values.
The equations we plan to use to analyze the swing of the golf club are derived from the kinematics of rigid bodies. The first two equations outline the principle of uniformly accelerated rotation. Since we are assuming constant uniform acceleration, these equations are best suited for this particular scenario. The next set of equations define general plane motion of rigid bodies and can be used to find the velocity and acceleration of these rigid bodies. Finally, the last two equations cover motion in relation to a relative and a fixed axis and can relate two fixed objects' motion together.
Here we have a short, slowed-down clip of the golf swing we used in our project. We began our procedure by filming a golf swing. We then analyzed the golf swing to determine our known and unknown variables. To determine our initial known variables, we set an initial position which we chose to be the fully cocked position, where the golfer has his shoulders fully turned and the golf club above his head. Through calculations in the freeze frame given on the right, we were able to determine our initial known variables to be our club length, which was 0.940 meters, our arm length, which was 0.635 meters, our time, which was 0.63 seconds, our change in theta 1, which was 155 degrees, our change in theta 2, which was 112 degrees, our initial velocity, which is 0 meters per second, and our angular velocity, which was 0 radians per second.
So in order to begin the analysis of the golf club swing, we use the first accelerated rotation equation and input the found change in angle of both the arm and the golf club in order to find the angular acceleration of both of these fixed objects. With this information, we could then find the angular velocity at the moment before the golf club strikes the golf ball, using the second uniformly accelerated rotation equation. These two factors are important for solving the general plane motion equations because they are dependent on the angular velocity and angular acceleration. The results of these equations are the velocity and acceleration of each individual rigid body, in this case, the arm and the golf club. Finally, we can relate all these variables together using the equations for absolute velocity and absolute acceleration. By inputting all of the previously found variables of the swing into the equations, we can define the absolute motion at the head of the golf club before impact.
To determine our initially unknown or final known variables, we use the final position, which is where the golf club is come into contact with the golf ball. We determined our final known variables to be the radius absolute, which was 1.575 meters, our velocity absolute, which was 24.813 meters per second, and our acceleration absolute, which was 301.979 meters per second squared, acting at an angle of 82.51 degrees.
As representation of our analysis, here's a graph representing how the absolute velocity and the absolute acceleration changes during the time of the golf swing, up until the moment before impact. As you can see, although we made the assumption that the acceleration of individual rigid bodies were constant, the absolute acceleration and velocity have increased in a non-linear fashion due to the Coriolis effect. Because the technique of a golf club swing inherently utilizes this effect, a larger acceleration and velocity can be produced, rather than if the swing were to be executed with a single rigid body.